Hello everyone, welcome back to our channel Everyday E-Learning. In today's video of Digital Logic Design, we are going to cover the topics BCD, BCD to decimal conversion, invalid BCD codes and Bcd addition. Now let us first know the full form of BCD. So BCD stands for binary coded decimal. Now let us learn the definition. So the definition of BCD means that each decimal digit 0 to 9 is represented by binary code of 4 bits. Sorry, this will be our binary code of 4 bits. Now let us understand how to convert a decimal number to its BCD form. For example, we are taking the number randomly 98. Now we will convert 9 and 8 into its corresponding binary number, but we will use 4 bits representation. So if we convert 9 to binary, we'll have 1001, and for 8 we will have 1000. Now if we take a shorter one, for example 35, we can represent 3 using 1 1, but as we need 4 bits representation, we will include 2 zeros before that, and for 5 we'll take 101, and as for same we need 4 bits, we will include 0 before 101 as well to make it 4 bits. Now if we go on the opposite way, for example we are given the following BCD code 0 1 1 1 and 0 1 0 0. Now these two are together. I kept a space in between for you to understand that these are separated 4 bits each. Now if we convert 1 1 1, then we have 7, and if we convert 0 1 0 0 to decimal, we get 4. So in this way we can convert decimal to BCD, and we can also go the other way around, decimal to, this is BCD to decimal. Alright, now we are done with the first two checkpoints. Now let us see the invalid codes before we move on to BCD addition, because that is important to know before we perform any BCD addition. Now there are 6 invalid codes in BCD, or we can term those as 6 invalid BCD combinations. They are 1010, which is 10 in decimal, then 1011, then 1100, then 1101, then 1110, and then 1111. Now if we convert them to their corresponding decimal values, we get 10, 11, 12, 13, 14, 15. So you see here, let me take a different color. We are using 0 to 9, which is represented by its binary code. So after 9, all these are considered to be invalid. Now you will understand the concept of invalid BCD when we perform BCD addition. So let us take an example and understand how we can do BCD addition and what the invalid combinations mean. Now we will start with a very basic example of BCD addition. BCD addition. Number 1. Let's add 0 0 1 1 with 0 1 0 0. So normally this is 3 and normally this is 4, and if we add them together we get 7. So we also should get the corresponding binary value of 7 in here. Now let us do the BCD addition here. So if we add this one according to binary addition, which we discussed in the previous videos in this playlist, so the result will be 1 1 1 and 0, and the corresponding decimal value of 0,111 is 7. Now let us move on to another example, number 2. We will add 0, 0, 1, 0, 0, 0, 1, 1 with 0, 0, 0, 1, 0, 1, 0, 1. Now if we convert these into its corresponding decimal values, they are 23 and this one is 15. So if we add 15 and 23 together, we get 38. Now let us add this binary number. Now for BCD, we know that we have to take four separate bits, so we separate them before we perform the addition. We have this separating point here. This is the alright. Now let us perform the addition. So if we add this one, we get 0, 0, 0, 1, and for this one we get 1, 1, 0, 0. Now if we convert this binary number into its corresponding decimal form, we get 38. So still we have no invalid numbers here because all of these are less than or equal to 9. Now we'll take an example where there will be an invalid number. Example number 3, we will add here 1, 0, 0, 1 with 0, 1, 0, 0. So the corresponding values are 9 plus 4, which is 13. Now if we add them, we have 1, 0, 1, 1. Now we see the value that we have here is this one, 1. If you can see above, this one, 1, 1, 0, 1. So this one is invalid BCD number, invalid because it's greater than 9. So we'll have to convert it to its valid form. So we can convert it to its valid form by adding plus 6 in binary form with its 4 bits. Now if we add plus 6, the binary corresponding number of 6 is 0, 1, 1, 0. If we add this, we get 1, 1, 0, 0, 1, and we include these zeros to make it separate 4 bits. So we get here, this one stands for 1 and this one stands for 3, in total 13, which matches with this one. Now we'll take another example for better understanding. So in this example, we'll take 0, 0, 0, 1, 0, 1, 1, 0, and we'll add it with 0, 0, 0, 1, 0, 1, 0, 1. Now the corresponding values are 16 and 15. So if we add them up together, we get 31. Now we will separate the 4 bits before we perform the binary coded decimal addition. Now if we add these numbers together, we get 1, 1, 0, 1, and for this part we get 0, 1, 0, 0. Now if we divide the 4 bits here, we can see that this part is valid, this part is completely valid as it is less than 9, but this part is invalid. So when it is greater than 9, it is invalid. So we add plus 6 with only this part. So we add plus 0, 1, 1, 0 with this part only to make the whole number valid. So if we add them, we get 1, 0, 0, 0, and for this part we have 1, 1, 0, 0. So this is now 3 and this is now 1, and this matches with corresponding this one. Now we'll move on to our last example, which will be a bit more different. Now we'll add 0, 1, 1, 0, 0, 1, 1, 1 with 0, 1 0 1 0 0 1 1. So the corresponding values are 67 plus 53, which is in total 120. Now if we add them up together, we have for this one 0 1 0 1, and for this one we have 1 1 0 1. Now we can see here that both this one and this one is invalid. Both are invalid, as both are greater than 9. Greater than 9. If we move above, we can see that 1011 and 1010 both exist here, so both are invalid. So we'll have to add 6 with both of them. So we add separately with the 4 separate bits. We add 0 1 1 0 with this one, 0 1 1 0. These are 2 separate parts. So if we add them, we get this one, we have 0 0 0 0, then we get 0 1 0 0, and then we get 1 0 0 0. Now if you have any confusion with the addition, you may see our video of how we perform binary additions. I'm not going to explain that in this video as it will get longer. So you see that if you divide it into individual 4 bits, it has 3 parts. So it is 1, and this one is 2, and this one is 0. So it is equal to its corresponding value here. So you see that if there are 2 separate portions, you need to add 6 separately with these 2 portions to make it valid. So this result is now valid in terms of BCD. I hope this is clear to you all. If you have any more confusion, feel free to write down below. Thank you for watching our video.